This one's going to be kind of interesting. All right, so the mapping below represents a quadratic function. Remember, a quadratic function makes a parabola. All right. So I'm going to make a table with this quadratic function. I don't like function maps because they're not easy for me to read, so I usually convert them to a table. So I have -2 in this x, and this is pointing to what? To -3. So that's the y value that it goes with. -1, 0, and 2. Let's put it all down. -1 points to -3.75. This is negative, sorry. 3.75. 0 points to -4. And 2 points to -3 again. As you notice here, the y value repeats, but that's okay. Y is allowed to repeat. It is still a function. If you see x values repeating, that's a red flag. It's likely not going to be a function. But this one is so far. So which relationship shows the number of, well, which representation shows the same relationship between x and y? If I have a table that I've created, I really want to put it in a spreadsheet. That's what I'm going to do. Okay, this is the best way to go about this problem. So you have a calculator. We're going to put this table in a listing spreadsheet. Okay, so I'm going to get the calculator out, and it's going to be -2, -1. So what I do is go to a new document, open a new document, don't save, add a listing spreadsheet. I'm going to call this X. I'm going to call this column Y, and I start putting my numbers down. Okay, let's take a look at this. -2, -1, 0, 2. -2, -1, 0, 2. Put all my x values down from the table. Now we can insert the y values. These y values are -3, -3.75, -4, -3. All right. So -3, -3.75, -4, and -3. They told me in the question that this is a quadratic function. It makes a parabola. Your calculator can model this as a quadratic function if you give it the right commands. So now that I have this table inserted, I'm going to go to Menu, Statistics, Stat Calculations, and I'm looking for one that says quadratic, and there it is. The question tells me it's quadratic, so this is what I'm going to select. Now it's going to ask me, what did you call your X list? Okay, I called my X list X. Okay, that's what I labeled it on top. So if I hit the drop down, there it is waiting for me. It's already stored. The Y list is Y, and I'm going to store this regression into the function f1. And then I hit OK. What it actually does is gives me the A, B, and C terms of a standard form equation for a quadratic, which we learned in class. But I actually want to make a table so I can compare it to the other answers. So I need to graph this, even though I have all this information. So to make a graph of this, I'm going to hit Control Doc, and I'm going to add a graph. What you should notice right away is that it says F2 on your command line. Okay, I stored the function into F1, so to make it show up, I hit the up arrow on the calculator. It's already stored from the regression I created, so I hit Enter, and it'll actually graph it for me. Now the reason I make the calculator do it this way instead of just going into a data and plotting the points that way is because I can create a table now. So what I'm going to do here is hit Control T and make a table. I am now going to compare this table with the answers and see which one matches. Okay, so let's take a look at your question again. This first answer matches -3 with 1.75. Does my calculator do that? So from here I'm going to go up to -3. And -3 goes with -1.75. Okay, so that's a -1.75, but this one here is actually a positive 1.75. So the signs are wrong. So this is actually not correct. This answer is bad. Okay, so now we're going to check this. Does this graph look like my graph? I really want to zoom in on that one. Okay, does this graph look like my graph? This graph crosses the y-axis at -4. I notice that's where the vertex is. So let's take a look at my graph. Let's just see if it compares at all. My graph also crosses at -4. Okay, my graph has x-intercepts at right here, which is -4, and this one at +4. Does theirs do that? No, theirs crosses at -2 and +2, crosses at -4 and +4. So this isn't the same. So this answer is also wrong. Okay, so we got rid of 2 answers. Now I'm going to look at this answer. Let's compare -4. On my table, -4 should pair up with -6 if this answer is correct. So let's try that. So I'm going to go up to -4. This -4 does not pair up with -6. This actually doesn't mean -6, so this is actually wrong. So this answer's got to be wrong. Since this order pair is not in my table on the calculator, this thing can't be right. The only answer that's left is D. Alright, and as a matter of fact, if you graph this equation onto the calculator, which is what, -0.25x squared minus 4, and I'll do that, it'll basically lay right on top of the graph I already have. So I'm going to get rid of this table, and I'm going to graph the function they gave me. That function they gave me actually matches the function I have. Let's go ahead and do another graph though. Hit tab. I'm going to graph that function they gave me for that answer. So 0.025 x squared minus 4. If this answer is correct for part D, then I should see just a different graph on the same thing. Okay, let's take a look at that. Oh, I made a mistake. I put an extra 0 in there. Let's try that. Okay, as you can see, it lays right on top of that graph. This is actually matching the same graph I already had. So this is actually the correct answer. It matches the exact same graph. So we'll select the answer D. Long-winded explanation, but this is how we're eliminating all of our answers. Okay, let's take a look at the next question, number 8 here. The slope of a line that passes through the points -1 in W and -10 in 4 is 1/8. What is the value of W? I suggest you use a calculator. This is a calculator problem. Okay, so basically when they give you 2 points, you should put this in a listed spreadsheet. So you have 2 points here. If you're writing it as an X and Y table, then your X values are -6 and -10. Your Y values, we're not going to say W. I don't really know what W is, and this other one's going to be 4. This unknown value for W, what we're going to substitute for that are these answers. We're going to plug these in for your W one by one. So let's try this, and we're going to try to get a slope for this line that's equal to 1/8 by substituting these values. Alright, so let's open up a calculator. Okay, from here I'm going to create a new document. Don't save, and I'm going to add a list in the spreadsheet. So I'm going to label this my X and label this my Y. Let's take a peek at these values again. So I need -6 and -10. Alright. Okay, so I need -6, -10. And here I'm going to need 4. So it's this right here that I'm going to start substituting values. So I'm going to go check my first answer here. It says F is 36. So I'm going to substitute 36 into this table. I'm going to put this in here. This is going to be my W value for the time being. And then I'm going to create the equation of this line using the calculator. And then I'm going to check the slope of this equation it creates, and hopefully it's going to be 1/8, which is what I want it to be. So I'm going to go to Menu, Statistics, Stat Calculations, and you're looking for line, linear regression, mx plus b right here. So I select this, my X list. I'm going to click the drop down. I called that X. That's what I labeled the column. The Y list, I labeled that column Y, and I'll save this regression into F1, and I hit OK. It tells me that the slope of this line, if this value is 36, will be 8. Okay. Keep in mind though that this is not supposed to be 8, it's supposed to be 1 over 8. So this answer is wrong. Okay, this gave me the wrong slope. So this one's wrong, I'm going to cross this out. So now I have to try 34. So I go back to the calculator. And I'm going to go back to this value here. And I'm going to substitute 34 instead of 36. Go back to this value here, and I'm just going to type in 34 instead of 36. When I hit enter, it actually changes the slope. All right, it changes it to 7.5. 7.5 is way bigger than 1/8, so this answer is also wrong. All right. Okay, now they want me to try h, 9 over 2, so we'll substitute that. So I click over here and I just set 9 divided by 2, just like it says. What this gives me is a decimal answer that's less than 1, so they say the slope here is 0.125. Now I'm not really sure what 0.125 is as a fraction, and because my slope is a fraction, it's 1/8 in the question. So I can make the calculator tell me what that is. I'm just going to go over to the scratch pad right here, and I'm going to type in 0.125, which is the slope it gave me, and I want to approximate this to a fraction. So I can go to Menu, Number, Approximate the Fraction, and then hit Enter. Hey, what do you know? 0.125 is actually the same thing as an eighth. And the eighth, as you recall, is what I wanted. I wanted this to be an eighth. So this is actually the answer for W. If I plug this in a W, I'll get the slope that's required. So this is the answer. It's H. Okay? This is all calculator work right here. It's just calculator play. So don't worry about actually doing a whole lot more than that. Let's go on to the next question with this. All right, number 9. Let's make this wider so I can see it. All right. So this is a question here. Actually, I can't see that too well. This is a question here about population of Webb County, Texas from the year 2000 to 2010. And what's happening here is the population is increasing. And this is the number of years since 2000. So 0 right here represents the year 2000. This will be 2002, 2004, 2006, and so on. All right, so the question that they're asking me, if this trend continues on the graph, what would the population of Webb County be in 2015? As you can see, this stops here at 2012. It doesn't go to 2015. So that means I'm going to have to extend this data. This is called extrapolation. I'm going to take this trend line and I'm going to keep it going. Since it's linear, I'm going to keep it going further. All right, so this is going to be 2012, there'll be a 2014, and a 2016, and then somewhere in the middle there'll be a 2015 out here. Okay, so what I'm going to have to do is kind of guess what the population will be at that time. So I'm going to say 2015 is right about, yeah, it's actually about here. And they want me to guess. So if I take this data and extrapolate it and make a guess, my guess is going to be about 275,000 people. That's just a guess, and let's see what the closest answer to that is, because my guess could be off. The closest answer, 275, there's actually only one reasonable answer. It's going to be about 278,500. All right, so it's pretty obvious this has to be the answer. None of these are even really close. So that will be your solution. It's really just an estimate, okay? Don't spend a whole lot of time on that. All right, number 10. This is a wordy problem, but let's take the time. It's not that much work here. So we're going to say a city employee paints curbs in parking lots and replaces road signs. Okay, it takes half an hour to paint a parking lot, a curb, and 2.5 hours to replace a road sign. The function below can be used to find C, the number of parking lot curbs the employee paints when he replaces R road signs. Okay, so they're telling me basically C is the number of curbs. And R is the number of road signs. It's important that you understand that. That's all. That's all you're getting out of this, really. The employee painted 20 curbs a week. So 20 here is the number of what? It's the number of curbs. It gave you the value of C. So I'm going to substitute 20 into C. And I'm going to rewrite this equation. But the only thing they can really make you do now is figure out the unknown value of R. And of course, what are they going to ask you? How many road signs? The number of road signs is R. They want you to find R. This is a single equation, so this is a calculator. Use a calculator. Single equation solving for a single variable. That is a menu 3-1. This is an insolve that we're going to use in the calculator. So let's go ahead and get the calculator out. Alright, so I have my calculator. I'm going to add a calculator. I'm going to go to menu 3, and then 1 is the numerical solve. And then we'll type in our equation. So let's take a look at that, take another peek here at the question. So it's 20 equals a fraction. Alright, so 20 equals 40 minus 2.5r over 0.5. Alright. So on the calculator here, so in my calculator I'm going to say 20 equals, and then there's a fraction. To make a nice fraction in the calculator, you'll hit Control Divide. So that's what you should do on your test. Every time you make a fraction there. So this is going to equal, what does this say here? 40 minus 2.5. All right. So I'll say 40 minus 2.5 r, and on the bottom I had 0.5. I want to solve this equation for r, and you must tell the calculator that. The calculator doesn't know what you want it to solve for. So you'll hit comma r. This tells the calculator to solve this equation for r. You hit enter and it tells you r is 12. Alright. So you look at your answers. Is 12 an answer? Well, sure is by the looks of things. So this answer is J. And then you move on. Don't spend too much time. This reading part, it can get you bogged down. It takes up time. And students, you know, some of them are in a hurry and they get worried. But take your time. You have plenty of it. Number 12, a rectangular prism has a width of x inches, a length of x squared y inches, and a height of y squared inches. This is actually only complex because you have to know what a rectangular prism is. It's a three-dimensional solid. Okay, you draw a rectangle. And then I'm going to kind of try to draw a box or a rectangle shaped box, which is called the rectangular prism. And there are three dimensions to this. There's a length, a width, and a height. They tell me that the width of this is x inches, so I'm going to make this little side here x right here. The length is x squared y. And of course the height, they tell me, is y squared. So this distance is y squared. They say which expression represents the volume. If you remember the volume of a three-dimensional rectangular prism, we have a volume is equal to all these dimensions multiplied by each other. Length times width times height. So what they really want you to find is this times this times this. Okay? There's not a whole lot of easy ways to do this with the calculator unless you want to get creative with substituting values into x and y. But to be perfectly honest with you, this is really one you should be able to tackle without using a calculator. So v, we're going to multiply the x's here. So I'm going to look at the exponents. This x has a power of 2, this x has a power of 1. When you multiply the x's, you add the powers. So 2 plus 1 is 3. So this will be x to the power of 3. And I've used these all up. Now this y has a power of 1, and I'm multiplying y by y. So y times y, add the exponents, 2 plus 1. So this will be y cubed. This is your volume. This is the answer. That's about it. Okay, we're going to skip down to number 13 here. The graph of line T is shown on the grid. So this is a line called T. The line W, so they're talking about a second line that we actually can't see. They're going to make one, is steeper than line T and has a y-intercept that is below the y-intercept of line T. Well, what's the y-intercept of line T? Alright, because I want to figure out which equation represents line W, the new line, and this new line has a y-intercept that is less than the intercept of yt. The intercept of yt, where it crosses the y-axis, is right here, and this value is 2. Okay, so here's the y-intercept of t, and they're saying it's 2. This new y-intercept will be below the y-intercept of t, so this y-intercept has to be less than 2 for the new one. If you recall, lines are written in this form, mx plus b, very typically. This is the slope, and this is the y-intercept right here, this number by itself. It's called the y-intercept. It's not multiplied or by anything here. This y-intercept in this case is 2, and I need a number that's less than 2 for the new y-intercept. So let's check out the answers. These numbers here on the end are y-intercepts, all of them. Which one of these are less than 2? Quite obviously, these two values of 4 are not less than 2. Okay, so only -1 is less than 2, and so is this other one. So you've eliminated half your answers just by knowing that little fact. Now you can make an educated guess if you had to, but we're not big on guessing. The only thing different between these two equations here is the slope. You have this slope and this slope. And what they told me is that line W is steeper than line T. Let's actually figure out the slope of line T. Alright, and this is going to be a little tricky, but I'm pretty sure we can manage it here just by kind of eyeballing it. If I say the x-intercept here is 5, 0, then I'm going to go from here to here. So I'm going to go down 2 and over 5. So I'm going to actually say the slope of this is -2/5. Alright, that's not very steep actually. And we have to find out a fraction that's bigger than 2/5, okay? So here's the real question. Which fraction, if I ignore the sign here, if I ignore this negative, ignore this negative, which fraction, 2/3 or 1/4, is actually bigger than 2/5? Okay? As it turns out, 2/5 is actually bigger than 1/4, so this can't be possible. This is actually shallower. So I'm going to get rid of this knowing that. So this answer is correct because 2/3 is in fact a bigger number than 2/5, and therefore it'll be steeper. So your answer is A for this one.